Okay, guys, this time I'm going to show you how we sketch the graph of an absolute value function. The first thing I'm going to show you is what is the reference function we use so that from that reference function, we get to know how the others go. So right now I am writing the function y equals absolute value of x. This is a straight line that has an inflection point right here at 0, and the first half of it goes like this. Excuse me, I'm not the best drawer here. And then it just goes up like this. This is the graph of absolute value of x. So just take a look at how we do this whenever we have a transformation. As you include more things in here, inside the absolute value or outside, adding or subtracting or multiplying, those are the three possibilities we're going to see, then you will see how it changes. So, for example, this time I am subtracting 2 to each value of x. So you might think, oh, this is going to be translated 2 spaces to the left, but this one is the one that is contrary to your logic. So instead of going 2 spaces to the left, you're going to go 2 spaces to the right to see where this point goes. Yeah, the minimum point. And then it's going to keep the same shape, just like that. Look at this. And that is the graph of y equals absolute value of x minus 2. The red one. Okay, keep that in mind. So it means that anything that is subtracted here, whatever units you have, it's going to translate it 2 units to the right. Well, translate it to the right. If you had a plus, then you would translate it to the left. Okay, now let's do another example where we're going to see 1 transformation, 2 transformations, 3 transformations. So let's take into account our reference function. I think that it is always necessary to have it as a reference. Look at this. This is how it opens. As you can see, for example, the slope, here you go 1 to the right, 1 up, 1 to the right, 1 up. This is how it goes. Okay? But now we're going to sketch the graph of this function, -2 multiplied by the absolute value of x minus 1, and then you add 3. So let's use red again, and I'm going to do this. These are 3 transformations this original function is going through. So the first thing is that this point that we call the vertex is going to be translated 1 unit to the right because there's a negative. So you would have it here. And then this 3 means that the vertex is going to be translated 3 units up. So it's going to be right here. This is one thing to take into account. So the tip of the absolute value graph will be over here. There is something you need to take into account. This negative sign will make it go, instead of facing this way, you call it concave up. Now it's going to go this way, like this, all right? Because of the negative value. And because of this too, we now have something we call a stretch. It means that instead of being this, like, the width or the thickness, now it's going, the width, it's going to be something like this. It's going to be thinner, right? So remember what I mentioned about this 1 to the right, 1 up, 1 to the right, 1 up? So this 2 will represent this. You go 1 to the right and 2 down, 1 to the right, 2 down, and so on. All right? And same thing to the left. 1 to the left, 2 down, 1 to the left, 2 down, and so on. So now that graph for this whole thing will be something like this. I'm going to try and connect these dots like this, and same thing over here. And that's it. Can you see that it's thinner? It's, we flipped it upside down, and the vertex has been translated one step to the right, or 1 unit to the right and 3 units up because of this. 1 unit to the right and 3 units up. And that's it.